that now the partitions are free to move without any friction, right? So in this case, both of them will follow an isobaric process. The upper part will follow an isobaric process, and because its pressure will be constant, the lower part's pressure will be adjusted such that it also follows an isobaric process. So the equation will now be 2 into Cp for both of them. 5 by 2R into 700 minus 3 is equal to 2 into 7 by 2R into 3 minus 400, which gives me 3500 minus 5t is equal to 70 minus 2800, which gives me 12t is equal to 6300, or t is equal to 6300 by 12, which is 525 Kelvin. But we are not asked the temperature, we are asked the total work done by the gases till the time they achieve equilibrium. Right? So that's easy enough. We need to find out, because these are isobaric processes, for both of them the work done will be P delta V each. Right? P is constant for both of them, and delta V then will be the change in volume. So for both of them we can use in an isobaric process V1 by T1 is equal to V2 by T2. And let's assume initially the total volume was V. Right. So initially the total pressure obviously was the same because it's free to move. So that means initially the volume was divided into the ratio of temperature. This is 400 and this is 700. So this is obviously 4V by 11 and this is 7V by 11. Right. I hope nobody's confused on how I got this. This is 4x, this is 7x. Their sum will be the total volume V. Right. So when we apply this to both of them, V1 for the upper one will be 4V by 11. So we get 4V by 11 divided by initial temperature 400 is equal to V final divided by the final temperature 525, which gives me, this cancels with this 100. So V by 1100 is Vf by 525. So Vf is 525 by 1100 V. Okay. Similarly, 7V by 11 by 700 is equal to Vf for the second one. So let's say this is 400. So this is V upper final and this is V lower final divided by 525. So we get the same thing final in this case. V lower final is equal to 525V by 1100. Right. They don't need to add up to V because the total volume does not need to be constant. So these are the two final cases. Right. Let's assume the pressure throughout is P. We'll calculate its value at the end. So the work done by the first one, by the gas, upper gas, will be P delta V. So P into 525 by 1100 minus 11 by 4, minus 4 by 11. Minus 4 by 11, which is 400 by 1100. So this is the upper one. So the work done by the upper one is equal to P, and there's also obviously a V here. So it is PV times 125 by 1100. Similarly, the work done by the lower gas will be PV times. Now in this case the volume has increased, but in this case this is less than 7 by 100. 7 by 11V, which is 700 by 1100, so the volume has decreased. So the work done will be negative, and it will be PV times 700 minus 525, that is 175 by 1100. So the total final work done is the sum of this, that will be PV times minus 1 times minus 50 by 1100. 50 by 1100 is 5 by 110 is 1 by 22. So minus PV by 22, this is the work done. Now we can just calculate the value of PV by using any initial condition. Initially for the upper part, 2N into R into 400 is equal to P into 4V by 11. 4 and 4 cancel. So what we get is PV is equal to 1100 into 2 is 2200 R. So minus PV by 22 is equal to minus 100 R. So the answer to this question, question 12, is minus 100 R. This is question 12 by the way. Question 11 was the previous one in which we just calculated the temperature which came out to be 490. In this case we needed to calculate the work done which is minus 100 R. So the answer to this question is option D.